Hello, this is William from Visual Components. In this video, I'm going to show you how to model a turn unit conveyor. Now a turn unit, which you can see right now in the 3D world, it receives a box, and once the box reaches the middle of its table, it turns the box to flow into a different direction, in this case onto another conveyor. Now this tutorial requires essentials with modeling pack as well as the geometry of the component we're going to model, which you can find a link to in the video description. Now, whether you're new to component modeling or you just want to see how things work, feel free to keep on watching and listen to me. Alright, let's get started. The first thing you want to do is import the geometry of a component you want to model in the 3D world. Now you could just drag and drop the file into the 3D world. However, in this case, I'll go to the Home tab, Import Group, and click Geometry. I'll now open this file here called turnunit.3ds, and this is the file you need for the tutorial. So I'll click Open. And then in the Import Model task pane, notice there's not a lot of options for a 3ds file. So I'll just click the Import button here to import the geometry into a new component that is automatically selected for me in the 3D world. Now the next thing you want to verify is that this new component is centered on the 3D world origin, which is the recommended modeling environment for new components. So I have the component selected. I'll go to the Component Properties panel here. Notice the file name is the default name for the new component, turnunit.3ds. I'm using the world coordinate system, and the x coordinate, y coordinate, and z coordinate is at 0. Now this is the difference between using the drag and drop method for importing geometry. I could just drag and drop this 3ds file into the 3D world and the component would load it wherever the pointer is pointing to. However, this geometry import command here will always import your CAD file or your geometry file at the 3D world origin. The next thing you want to do is define the node structure of the component. In this case, I don't want the legs and base of the turn unit to rotate, but I do want the geometry of this table to kind of rotate in place. So I need to move this geometry into a new feature and a new node. So with the component selected, I'll click the Modeling tab, and notice here in the Component Graph panel, the root node of the component has the same name as the component. So with the root node selected, I'll actually go to the Component Properties panel here and rename the root node and component. So I'll call it Turn Unit. And I'll go back to the Component Graph panel, expand the node feature tree here, and notice all the geometry I imported into the component is contained in one geometry feature. And I need to move this geometry of the table into its own feature. To do that, I'll go to the Geometry group here, click the Tools arrow, and I'm going to use this command here called Split. So it's going to move sets into new feature. So in the Split feature task pane, I'll change the split level to Set to select Geometry Sets. And now I just need to select all the geometry of the table. So I'll directly select or click the roll bar here, and it's green, that means it's selected. And now I need to select all the other roll bars, so I'll hold down the Control key and click each roll bar. So green, green, green. Alright, let's make them all green. There we go. Let's now select the side rails, so I'll hold down the Control key and click this side rail here to add it to the selection. And I'll click the other side rail here. I also want to add this plate that's supporting the table to my selection, so I'll click here in the plate. I actually selected this circle object here, but that's okay, we need that in our selection too. So I'll select the plate there, and this is all the geometry you should have selected. So now I want to move this geometry into a new feature. So down here at the Split feature task pane, I'll click the Split button, and notice here in the Component Graph panel that geometry is now in its own feature. So if I select the original geometry feature, it just contains the legs and the base of the turn unit, but when I select the table geometry, it's in its own feature. So let's now move this feature into a new node. So I'll go up here to Geometry Group, click Tools, and there's a command here called Link under Extract. So this is going to extract the geometry I have selected or feature and move it into a new node in the component. So I'll click this command. Notice the new node is now selected and its geometry is highlighted blue in the 3D world. So if I go here to the Component Graph panel, you can see there's the new node. And if I expand this, here's its geometry. The next step is to define how the geometry of the table is supposed to move. So we know we want the table to kind of rotate in place clockwise or counterclockwise around a vertical axis, which in this case is the z-axis. To do that, we need to define the joint properties of the node containing this geometry. So go here to the Component Graph panel and click Link 1, which is the node I added to the component. I'll now go to the Link Properties panel over here, and I'll set joint type from fixed to rotational. Notice this adds some dynamic properties to the link or the node. Make sure the axis is set to positive z-axis or positive z. And under here in joint properties, notice the name of the joint is called J1, and it doesn't have any controller at the moment. So if I click this option here, since I don't have any servo controller or robot controller already set up in the component, I can click this option here called New Servo Controller. And what this does, it automatically creates a configured servo controller for me in the root node of the component, and it's all set up to control this J1 joint. So if I go to the component graph panel, you can see here under the root node is its behaviors. I'll click servo controller, and over here in the properties panel, notice that J1 joint has been added to the servo controller, so it can control it. The root node is correct, and so is the flange node. Now, if you want to test the degree of freedom or how the geometry in that link 1 node moves, what you can do is you can go here to the manipulation group, click the interact command, and now the joint properties of the node containing the geometry automatically define the mechanism of movement for the node. So when I interact with the node, notice I'm now moving the geometry of that table, and it's rotating in place around the z-axis. Beautiful. All right. So now I want to reset this joint value to 0, so I'll just use the simulation controls here and click reset, and it resets to 0, which I can confirm by clicking that link 1 node. And over here in the properties panel, notice that its value is at 0. The next step is to add a path for moving components along the table. To do that, you need to add frame features that the path can reference as points in the 3D world. So we need to have a point of reference at the beginning of the table, the middle of the table, and at the end. So let's go and create some frame features. On the modeling tab, I'll go to the geometry group and click the features arrow, and then click frame to add a new frame feature. Let's go ahead and rename this feature to be begin frame, and let's change its height. So I'll change its z coordinate to be 700, put it on top of the table, and let's move it back to the beginning of the table. So for the x coordinate, I'll type in -600, and you can see here there's the frame, but we really can't see the label of the frame feature in the 3D world. So to turn those on, I'll go to the 3D world toolbar, click the frame types arrow, and select this checkbox here called frames for frame features. And yep, there's the frame feature. Let's now create 2 more frame features at the middle and end. So same steps, go to the geometry group, click frame to add a new frame feature. Let's rename it to be mid frame and move it up to the top of the table, so z coordinate of 700. And we'll keep it at the middle of the table. So now let's add the end frame. Go to the geometry group, click features, then click frame to add the new frame feature. Let's rename it to be end frame. Change its height, so z coordinate of 700. And let's move in the positive x direction to place it at the end of the table. So for x coordinate, I'll type in 600. And there's the end frame. So we have a begin frame, a mid frame, and an end frame. So now we need to create the actual behavior of a one-way path so it can move components in one direction along the table. So go to the behavior group, click the behaviors arrow here, and under material flow I'll click one-way path to add that behavior. And now I need to assign these frame features to the path. So in the properties panel, I'll go to the path property here, click the expand arrow, then click the add button here, and now I can add those frame features to the path in the order I want to move components. So I'll first add the begin frame, the mid frame, and the end frame. Close this out. Now if you do make a mistake while adding the frame features, you can go to the path property here, and there are arrows for reordering the frame features, but so it should be begin frame, mid frame, and end frame. So I'll collapse this out, and we can go on to the next step. The next step is to add a sensor and signal to the path that can detect when a component reaches the middle of the table. Let's start by creating the signal. So on the modeling tab, I'll go to the behavior group, click the behaviors arrow, and then under signal I'll click Boolean to create a Boolean type signal. Let's rename this to be center signal, and let's now create the sensor. So I'll go back to behavior group, click the behaviors arrow, and then under sensors I'll click path. So this will create a component path sensor, and I want the sensor to be located here at this mid frame of the path. So in the properties panel I'll set frame to be mid frame, and when the component goes over the sensor, I want the sensor to be triggered at the component's origin. So when the origin of the component reaches the sensor, I want it to be triggered, and I'll also reset it. Now I want to signal when that trigger happens. So for Boolean signal property here, I'll set it to be center signal. So when the sensor is triggered, it'll send out that signal of a true value. And when the sensor resets, it'll send out a value of false. Let's now add the sensor to the path. So I need to go to the component graph panel, select the one-way path, and then in the properties panel, I'll go to the sensors property here, click the expand button, followed by the add button, and here I'll just click component path sensor to add it to the path, and there it is. So let's go and collapse that and go on to the next step. The next step is like the previous one, where you need to add a sensor and signal to know when parts leave the table. To do that, on the Modeling tab, go to the Behavior group, click Behaviors, and under Signal, create a new Boolean type signal. Let's rename the signal to be Exit Signal. Let's now create the sensor. So go back to the Behavior group, click the Behavior 0, and then under Sensors, I'll click Path to add a new component path sensor. And we need to position the sensor here at the end frame. So in the Properties panel, I'll set frame to be end frame, and we need to trigger the sensor at the trailing edge of the component. So as the last part of the component is leaving the path, that will trigger the sensor, and we'll also reset the sensor at the trailing edge. And for bool type signal, we'll use exit signal. So when the part leaves the path, it'll send out a signal of true, and when the part's completely gone from the path, it'll send out a value of false. Let's now add the sensor to the path. So in the component graph panel, I'll click one-way path, and then in the properties panel, go back to the sensors property, expand it out, click the add button, and now let's add component path sensor 2, like so. And there you go. So I'll just collapse this, and let's go on to the next step. The next step is to add interfaces for transferring components into and out of the turn unit. Now, since the table of the turn unit will rotate, I need to have fixed points references in the component for where parts enter and exit from the turn unit. So I know I want parts to enter here at the beginning of the table, flow along the path, and then exit out the other end. Now the table will rotate, so there probably needs to be an exit frame over here to the side of the turn unit. Now to create these frames, I'll go to the component graph panel, select the root node, and then in the geometry group, I'll click the features arrow, and then click frame to add the frame feature. And I'll rename this frame feature since the names need to be unique. So I'll type in enter frame. So this will ID where parts enter the turn unit. I'll set it to be the same height as the table, so a z-axis of 700. And I want it to be where the begin frame is as well, so I'll change its x-coordinate to be negative 600. And here's the frame. So when the table rotates, notice that the enter frame stays put, but the path of the table rotates with the table. Okay, so let's reset that. Let's now create an exit frame over here to the side of the turn unit. So go back to the geometry group, click features, and then click frame to add the frame. Let's rename this to be exit frame, so this will mark where parts exit the turn unit. So I'll put it the same height as the table, so z-axis of 700. And now we need to transfer this frame feature over here to the side. So I'll use the move tool, and we're going to be translating along the y-axis, so I'll change the y-coordinate of the frame to be 600. And notice now when the table rotates that the x-axis of the frames will be pointing in a different direction than the exit frame. So I need to rotate this frame about 90 degrees along the z-axis. So for RZ, I'll type in 90, and that's good to go. If you want to double check, just change the coordinate system to object. You can see the x-axis of the exit frame is pointing in that direction, and when the table rotates, notice that they're going to line up like that. Alright, so let's reset that. And now let's create the interfaces. So we need to create an enter interface over here and an exit interface over here, so parts can plug into this component here as well as there. So in the behavior group, I'll click the behaviors arrow, and then interface, I'll click one-to-one to add a new one-to-one interface to the root node, and then create a new section or plug. I'll now position this section to be at the enter frame. I'll add a new flow field, so parts can flow from one container to another container. So the container here will be the one-way path of the table, and the path needs to receive parts, so they need to come through the input port of the path. And this interface is good to go, so let's go and create another one for the exit frame. So go to behaviors, click one-to-one, let's add a section or plug for that, so that will be at the exit frame. Add a new flow field, and now parts are going to flow out of the path into another container. So here the container is one-way path, and the port is going to be the output. So once again, to explain what I just did, I created two frames in the root node of the component, so when the table rotates, those frames stay put, as well as the interfaces or the connections to other components. So let's reset the simulation to return the joint to its 0 value, and go on to the next step. It's now time to add logic to the component that controls when the table of the turn unit rotates to flow components in a different direction. To do this, we're going to write a Python script. So get your coding face ready. Rah! Alright, here we go. So in the component's root node, I'll go to the behavior group, click the behaviors arrow, and then under miscellaneous, I'll click Python script to add that behavior to the root node. And it's good practice to keep your Python scripts in a component root node so they're easy to find. Now in our script, we're going to use the signals of the sensors to act as triggers. So I need to connect the signals to the script so when the signal value changes, the Python script knows about that event. So I'll minimize the script editor, and then in the component graph panel, I'll click Center Signal, go to the Properties panel, and for the Connections property, I'll click the Expand arrow, followed by the Add button, and then in this dialog here, I'll click Python script to add it as a connection to the signal, like so. Let's now do the same for the exit signal or the exit sensor. So in the component graph panel, I'll click Exit Signal. I'll now go back to the Properties panel, click the Connections Expand button, followed by the Add button, and then click Python script to add it as a connection. So when a part reaches the mid frame or that mid sensor, the script will know, and when a part exits that exit sensor, the script will know as well. Let's now go back to the script editor. So I'll go down all the way down here and open back up the script editor. Now by default, the script will import VC script, and this has some helpful methods for getting handles for a component, the application and simulation, as well as getting other handles for other objects. So the onRun function here, or event, is the main loop in your program. So we first need to get handles or variables that reference objects. So we need to get a handle for the component. So I'll type in comp equals get component, and this method will get a handle for the component containing the Python script. I can now use this to get other objects in the component. So I need to get a handle for the servo controller. So I'll type servo equals comp.findBehavior, and this method searches through all nodes of the component to find a behavior with a specific name. In this case, the servo controller has a default name of servo controller. I now need to get a handle for the path, so path equals comp.findBehavior, and the name of the path is one-way path. Let's now get a handle for the application, because we're going to write a loop, so I'll say app equals get application. And now I'll get a handle for the simulation itself, so that's a property of the application, so sim equals app.simulation. And now we need to write our main subloop. So while the simulation is running, so sim.isRunning is equal to true, I'll now create a subprocess for tasks I want to keep on being looped while the simulation is running. Now, in some scripts you might see people write while true. You can do that, but it is prone to mistakes, so using the simulation while it's running is a safer loop. So now, while the simulation is running, we're going to wait for that mid sensor to send us a signal. So we're going to use a method called trigger condition, and this is available in VC script. And I'll write an expression here. So I'll first get the trigger using this method, and if the value of that trigger is equal to true, go on to the next statement. So it's going to wait for a signal to be received. It'll evaluate this expression. If the trigger to the script, if its value is true, then go on to the next statement. So the next statement is going to turn the path off. So I'll say path.enabled equals false. I don't want any more components to be received on the table of the turn unit while the table's rotating. That would be a mess. So I'll type path.capacity available equals false. And what I forgot to do actually is turn the path on at the start of my script. So path.enabled equals true, and path.capacity available equals true. And just to make sure that only one part is on the path at one time, actually we'll go back to the component graph panel, select the one-way path behavior here, and in the properties panel I'll go and set capacity to be 1, just to be on the safe side. I'll now go back to the script, And while the path is disabled, I'll go ahead and rotate the joint of the table. So I'll say servo.move. And this method allows me to move all the joints of the servo controller if I want. So let's actually move it 90 degrees. And after the servo controller rotates 90 degrees, I'll then turn the path back on. So path.enabled equals true. And I don't want to receive any more parts because the table's still kind of rotated. So I'm actually going to wait for another trigger, that exit sensor. So write the expression once again. So get trigger dot value equals true. So in this case, I know that the first trigger I'm going to get to the script is going to be that mid sensor. So as long as its value is true, I can then go on and rotate the table. I'm then going to wait for the part to exit the table, so I'll wait for that exit sensor to have a true value as well. And once that's done, I know it's safe to kind of rotate the table back and receive a new part. So let's do that now. So I'll say servo.move. I'm going to set its joint back to 0. And after the servo moves the joint, I can go ahead and set the path capacity available to equal true, so it can receive new parts. Okay, so let's go ahead and compile the code. So I'll click this button here called compile. And let's go ahead and exit out of the script editor. And now let's save the component before we start testing it with other components. So on the modeling tab, in the component group here, I'll click the save button. And in the save component task pane, let's keep the name of turn unit. You can add a tag if you want, let's say of training. And let's go ahead and click the save button down here. So go ahead and save the component. I'll save it as turn unit in my models. Alright, let's go back to the home tab. And in the eCatalog panel, I'll click the My Models collection here. And yep, here's my component. At this stage, our turn unit is ready to be tested with other components. We can also run a simulation to test the logic of our Python script. So let's first test the interfaces of the component, which you can see here as yellow arrows. I'll go to the eCatalog panel, expand models by type, and let me make this a bit bigger for you. And now I'll go ahead and click Conveyors, and expand that, and then click Visual Components. Let's add this component here called Conveyor. So I'll drag that into the 3D world. And now the conveyor should plug into that enter interface of the turn unit, like so. It's green, it's good. Yes! Let's now add another conveyor and connect that to our exit frame. So let's move it closer. And it should snap there. Yep, and it does. Let's now feed some parts into the table so we can test how the table rotates. So I'll add a feeder to the start of this conveyor here. Let's now go to our eCatalog panel and click Feeders under Models by Type. And let's add a shape feeder. So I'll drag that into the 3D world and plug it into the conveyor. And let's actually go ahead and turn off the frame features. So in the 3D world toolbar, I'll just click the Frame Types button to toggle all the frames off. Let's now run the simulation. Show me that magic. Alright, here's some boxes, they're moving. So the box reached the table, it stops at the center of the table rotates, and the box flows into another conveyor. Great. Alright, this concludes the video. If you have any more questions, please feel free to visit our forum at forum.visualcomponents.com. And as always, have a wonderful day.